Good morning. Thank you, everyone, for being here. My name is Dan Rosanova. The @ sign is silent. I'm here today to talk about disaster recovery and high availability in messaging solutions. Pretty pertinent topic for the cloud. The cloud is really distributed computing, if you're doing it right at least. So disaster recovery is an important aspect to that. This is actually a bit of a continuation from a talk I gave here last year, so I'm actually very happy to be back. This was, I think my messaging talk last year was the most engaged audience I've ever had at a conference, almost to the point where I was almost nervous. It was a lot of fun, so I'm really glad to be back here. This is a really good conference. It's the right size. I was at Ignite in the US last month, and there are 30,000 people there. And it's like being in a small city. That's just a little too much Microsoft for me. And so disaster recovery today, I actually have some new pictures I could have put into this. Disasters do happen. We're going to talk about what you can do about them and be prepared for them. And this really does extend last year's talk, which was all about stuff you have to do. But we'll recap that. So disasters happen on small scales, like this. This is a fun one. I was cutting some onions 2 years ago and sliced the end of my thumb off. That was a fun one. And I actually just had a big disaster right before coming here, crashed my bike. The pictures of that were too brutal. And disasters happen at large scales, too. I'm not going to talk about that one, though. So sometimes there are technology disasters. There are 4 terms that we're going to have to talk about that you might hear a little bit, and I want to express them from the way that we think about them in the Azure team, specifically in the messaging team. They're high availability, HA, people throw that around all the time, right? Disaster recovery, DR. Recovery point objective, RPO. And recovery time objective. And then there's the 9s. There's the myth of the 9s. And the one thing I want everyone to think about is, and people ask this all the time, they're like, oh, give us more 9s. We want more 9s in the SLA. 9s are kind of a myth, and you need to be really careful about how you think about them or people promising you them. Because one, just read the SLAs. Like if you read Amazon's SLAs or our SLAs, you'd probably be a little concerned about some of the language that's in there. The real thing to think about is real data. So for October 19th of this year, I took this snapshot of our messaging services. We had 514 billion messages in the 24-hour period. So 514 billion requests. And we had a 99.9991 success rate. I mean, that's 5 nines. That's like everyone's gold standard, right? You got 5 nines. Granted, that's over a short time window. But even over that short time window, we still had 4 million errors. So we still had 4 million messages that people sent that we said, hey, we couldn't save these, or we couldn't do something with them. That's 5 nines, and there's still 5 million things that went wrong. Like, this is a problem. Like, this is something you need to be aware of when you're thinking about not just HA, but DR. So let go of the 9s for a little bit. We'll come back to them later. They have an important part, but it's usually not a blanket sort of statement like people try to make. So let's go back to the beginner's mind. Let's forget about computers for a second and think about what these terms mean in like regular layman's terms. So I'm going to use some aviation analogies as a nod to Clemens on my team. Let's use the airplane analogy. You'll notice that every commercial airliner has 2 of these big round things on them, engines. That's because they're pretty important. If you lose one, you're gonna. If you only had one and you lost it, you'd be in a lot of trouble. The plane I flew here from LA had 2. So that's what that is, high availability, right? You're able to keep going. Granted, you're probably going to land pretty quick. One of my brothers flies for a major U.S. carrier, and he, once in his career, 30-something year career, I think, 25-year career, he's had 1 engine go out, and that's it. But he's fine, had a good time. So let's think about another aviation analogy, and I'm going to apologize ahead of time. They're very strict about copyrighted materials, so we're going to have some little drawings in here instead. Another aviation analogy, disaster recovery. So HA, yes, ability to keep going. Disaster recovery, the ability to survive, the ability to relocate to somewhere else. And when you're doing that, especially when you leave the HA sphere, which we'll talk about a little bit more, which kind of tends to be in a geography, and start looking at the DR sphere, you get important things like a recovery point objective. So how long is it taking me to get operational again? That's what that's about, right? Like, recovery time objective. How long is it from the time that the failure happens, like if US West, I don't know, Godzilla attacks California or falls off into the ocean, how long is it before your stuff's up running somewhere else? There's also a recovery point objective. The recovery point objective is a little bit more, well, and it depends on your usage, whether that's more important or less. It's how far do you have to backtrack in your journey to catch up with where you were. So that's kind of the easiest way to think about that. Where did I rejoin my journey? So my recovery point, was it 5 minutes ago? Was it the data from yesterday? And you need to think about those terms. RTO and RPO are the balances you're going to be trading off all the time. When you look at the recovery spectrum, here's kind of what it looks like. You have RPO on one side and RTO on the other side. And getting into this quadrant that's the darkest color is the hardest challenge you face. Using math symbols for either, or especially both of these, is generally not a good idea. Like, infinite is not a good RPO. Like that, you want to know what these are and you want to test them. Getting to the upper right is very hard. So it's a lot of work that you just have to do. And last year I talked about some things you can do, and this year I'll talk about some other things, but yeah, whatever. Some more surprise stuff too. So real quick, the messaging services in Azure, there are 3 of them. We have Service Bus, which we're kind of just calling messaging. This is like TIBCO or MQ series. It's a PaaS service. All of our services are PaaS. We have Event Hubs, which is a, I don't know, this definition I actually swiped from the Apache folks, but it's like a distributed log. You can think about it that way. High scale, low latency, distributed log. And finally, there's Relay. So Event Hubs, maybe Kafka is the best analogy you can make, or Amazon's Kinesis. Relay kind of has no competitor out there. We're going to make some big announcements next week on Relay that'll be pretty exciting. And I think shortly after that we'll probably have some competition out there. But Relay is a cool technology because it lets you do things like connect live sockets through firewalls and NATs without having to change any network configurations. So like VPN without VPN is a good way to think about it, especially about what we'll talk about next week. Now I want to talk a little bit about disasters in a technology concept, so mixing back in the messaging stuff. I'm not going to talk about Vista, so we'll leave that technology disaster behind. When we think about high availability in any system we build, this doesn't need to be cloud, just on-prem or something, what we're really thinking about is the ability to keep functioning, even at a reduced rate or scale, without any functional impact. This is why we do things like build recoverable solutions that can handle disk, server, or network failures. Traditional high availability is about removing single points of failure, like one switch or one port on the switch, one power socket. Like, you have to think about all these aspects of what can fail. Then there are non-recoverable things, which would include stuff like fires or floods, earthquakes. A small fire might be a minor disaster, but a large fire could be a really big one, especially if it's like in a data center or something. Earthquakes, Godzilla attacks, those are the kind of things that you're probably not going to use HA stuff to solve. You're going to have to move to somewhere else. Godzilla usually takes out a lot of the power infrastructure. And how we build stuff like this is we look at it like a picture like this. Is everyone familiar with this type of diagram, right? Where you've got some databases, you're probably using like mirroring or some sort of replication technology. Every database vendor provides that. That's your storage layer, right? That's where your state is really going to live. You've got a bunch of compute, probably in some sort of farm or cluster or something. You could be using, Service Fabric is what we use for this. And that's kind of your compute stuff. So your state's in one place, your compute's in another, and you're doing some network tricks like a load balancer to tie it all together. So what you're really trying to do is eliminate the single points of failure. Azure gives you a lot of stuff for high availability. Some of the stuff is automatic, like PaaS and SaaS solutions in Azure tend to do all that stuff for you. Or if not all of it, they do a lot of it. It's still really important to understand what they're doing and what they're not doing, and understand the context of that, and that it's going to be different with different services you're using in Azure, especially when you're mixing things like infrastructure as a service with platform as a service. There's still many knobs to control. We'll talk about a few of those in messaging space in particular. So there's still things to do here that don't necessarily make this easy. But you don't have to worry about power and things like that. We've solved a lot of the hard logistical problems already. When you look at things like VMs, VM scale sets or compute or something like that, like PaaS v1 stuff, we do a lot there for you, and increasingly more with things like Service Fabric or with functions and things like that. These are, when you get to the VM type stuff, is pretty critical to understand how your failure models work for HA. Because if you don't understand that, you're not going to be in a good place. A very good example is instances of VMs. right? If you don't have at least 2 instances, you're going to be in trouble. There are a lot more knobs to control here. So the kind of tough part on the infrastructure side is that this is where things like connection strings, like network configurations, these you'll probably have to switch when you're doing stuff in, to make stuff HA. Like if you have 2 database servers, unless you're using some sort of software load balancer, you're going to have to know about both of them. So how do we do HA in Azure messaging? The good news there is most of it's done for you, not all, but most. We're relying on Azure Networking, which is a giant software load balancer. It's very distributed, so whole servers can fail, whole racks can fail. Azure keeps going. At least that's the idea. We're using cloud services. This afternoon I'll talk a lot more about this, about how we actually run our stuff. The cool part about that, the focus of that talk, is that it's really with stuff that you can use also. So we've got some stateless front ends, which you actually talk to. We're behind the VIP, a stable IP or DNS that you'll ultimately talk to. And then we've got a second back-end role of cloud services where we run a service fabric ring that we install with an MSI. So not like the service fabric cluster you create in Azure, something very similar though. And that is also stateless though. So that's stateless services. We'll talk again about that this afternoon. And then our storage, so we've got network, compute, and storage. Our storage is either SQL Azure for things like basic messaging, or it's Blob for premium messaging or for event hubs. So both of those, they're triple replicated by Azure in that region. So we've got a lot of HA already. The important impact of availability is really on some of the features that you run. So some of our services are partitioned in some way, at most of them. I'd say all but like one of our services are natively partitioned because we're a multi-tenant platform. So think like event hubs, queues, and topics. The concept of a partition is in there. You cannot create an event hub with more than or with less than two partitions. So that's just a rule. And soon we will turn off the ability to create a queue with just one partition because we don't like that either. Some features are there to improve availability, things like partitioning. If you're using a queue, it should always be a partitioned queue. That's because we're going to run it on more than just one of those databases, more than just one of those backends. It means you're going to get a lot better availability for it. The number one support issue we have in service bus messaging is that people aren't using partitioned queues. And what might happen is the workload, again, this afternoon we'll talk about that in depth, but the workload might move from one server to another, and for 5 seconds or 10 seconds, it's unresponsive. And while that's happening, I mean, when you're running at a really fast rate, thousands of messages a second, they pile up real fast. So it's something to be aware of. Some features, though, do not help availability. Some features actually harm availability. And this is an important concept to kind of get your head around. I don't want to get too deep into messaging. Yeah, if anytime anyone does, just yell out. I'm happy to talk about it. It's my favorite subject. But things like partition keys, which we allow in all of our services, sessions, duplicate detection, these things all create partition affinity. Partition affinity is really about the CAP theorem. So the CAP theorem is basically saying that you can choose 2 of these 3 things: consistency, availability, and partition tolerance in a distributed system. So this is a hard, fast rule. You cannot have all 3. There's some cool computer science stuff behind this, Brewer's theorem. This is from Wikipedia. Go check it out. It's fun. I think this was made after my school days, though. But to put it another way, an easier way to think about what the CAP theorem is telling you is it's telling you this, right? Again, no copyright infringement here. That's my hand. So you have to make a choice here. You have to make a choice between consistency and availability. If you want to use something like a session in messaging or a partition key in event hubs, you are making a choice about which compute nodes you're going to be waiting for on our platform. And we don't really warn you. It's just like, hey, that's pretty easy. Let's use this. So what is the impact of this? The impact is if you're using a partition key in particular, that's just a good example by chance, you're making an explicit decision that you want to wait for one server and one data store. Now, our system will still move the servers around. So that service fabric ring will let us move quickly and reliably. We won't lose anything, but that is one thing that's available at that time. And so is the data store. And why do we have to have it this way? It's because when you want something like order, which is what a partition key is really giving you, you're getting to say, I want all the things for Dan in this specific order they're sent. You need to have an arbiter of order. And at some point, you get down to the point where, okay, distributed, but you have to make a decision. And there's one arbiter for that. So it sneaks into your code like this. And you're like, hey, that's easy. It's so useful. But you've really just made a really important decision here. And you might not necessarily be aware of what that decision is. If you're using Event Hubs in particular, I apologize. I used to tell everyone use partition key. It's the greatest thing ever. And it is for a certain class of problems if what's important to you is order and locality of data, which is a different challenge in distributed computing, especially big scale. So whether or not to use partition keys is a pretty difficult discussion. It depends what's most important to you. So another hand-drawn image here is that the real concept here is if you're going to use keying or not keying. And if you can get away from it, you shouldn't. If availability is the most important thing to you, you need to come up with another solution to get order. And there are a lot of other things out there. You can stamp messages with your own data. It's just packets flying on the network. You could say packet 1, packet 2, packet 3, and you can assemble them and get your own order. Now let's talk a little bit more about RTO and RPO and kind of what those mean. These are kind of abstract. Is everyone familiar? Who's heard these at work before? Like, who gets these things thrown around? And who can say that it's always made sense in the context that it's brought up, right? Yeah, no, exactly. These are fairly simple concepts, but we make them difficult in our organizations. One organization that I've worked with recently that did a very good job of making this easy to understand used a tiered classification system. I like this a lot. I'm actually using it a lot within Microsoft. And that's that you have a pyramid of applications. I was going to use a round shape like a bullseye, but with the color theme for this template, it really looked too much like a bullseye. So you have a lower tier of stuff, kind of tier 3 or ring 3 type stuff. It's not too important. This would typically be like clickstream stuff, weblogs, things that are useful. You can get a lot of information and value out of, and you probably have a ton of. But it's really sort of telemetry. It's not like real critical stuff. The next is you're going to have data that's pretty important. This might be stuff that like users are doing on your website. Like you don't want to lose the state in a session of a web app when your users are on it. That's like a really annoying thing when you're using a website and says, oh, you've been logged out, or like you're doing something halfway done and it resets you back to 0, or step 1. That's what this is. So it's important data, but yeah, it's not the end of the world. And then you get to data that's really critical, really core to what an organization is doing. This would usually be financial data. This would be something that's really kind of the center of an organization. And a lot of this stuff, the tier 1 stuff, isn't at a lot of organizations totally the cloud yet, but this whole idea still works in any organization. The easiest way to think about what this is with dollar signs, because it's what it costs to do this. If you've got a lot of telemetry, you need to think really hard. Well, is it important? All my clickstream stuff. I can assure you that Netflix, who's a big user of Kafka, does not care where I stopped watching The Sopranos last week. Like, it's important in a macro sense. For me in particular, it's not that important. It's like posting updates on Twitter or something. Like, no one really cares. You get to things like that tier 2, that's going to be pretty, more important stuff. This is where you're going to start. Tier 3, you can basically throw away. You can be real loose and weak with your RTO and RPO in a disaster recovery standpoint. You could probably run your business fine for some time without the telemetry. It's over time that you'll get degradation in performance that you want that telemetry. Tier 2 stuff, like that's generally customer facing, that's going to be painful. You'll spend more money on it, but the nice thing is you've already isolated now the vast majority of your communication stuff to say, hey, this is one level of stuff we're willing to follow one set of policies for, RTOs, RPOs, things like that. And now we've got 2 other levels that have those different numbers. So unfortunately, you're getting more RTO and RPO here, but at least you can get people off the conversation of being like, more 9s, everything's always available all the time. And it's possible. It's just really, really hard to do. So what are we providing in messaging? This is good because we don't usually explicitly talk about this. We actually do have an RPO of 0. So our recovery point objective in a region is 0. So unless California falls off the continent and falls into the ocean, your data will still be there. Even if there is a fire or something really bad, we test this all the time. The flip side to that is, and this is usually the trade-off between extremes, is that our RTO is not defined. So it might take us a day or a week to get your messages back in the queue that you want them out of. So I just want everyone to be aware of what our promises are so that you know what decisions you're making on that. Again, some of our features are going to cause you trouble if you don't know exactly what they mean. Something like receive and delete means just to take the data off a queue and just get rid of it right away, and I'll figure out what to do with it. That's fine until you have failures on your side. So if a database is down, you can't insert a record, whatever it is, you're holding stuff in memory, you've already told us to delete it. This is the fastest way to process, but it's also the least recoverable way to process. So you're making another decision there. We'll offer something else like a peak lock where you're leasing a message so you can actually know that you're getting through there. A key thing here is to understand for something like event hubs that it's at least once delivery model. You know, that's kind of how things are with the lease also. When you're leasing and locking, the lease expires, someone else can read the message. You might have processed it twice, so you need to know that. But you won't know that someone failed. You know, you can see the retry count, you can see other things. Just like in event hubs, you can read the data as much as you want, but at some point you have to take responsibility for what's happening next. Here's some of the HA stuff you need to be aware of for your side. That's what we're providing on our side. These last 2 points are important things you need to provide on your side. First, something I like to call the Noah's Ark theorem or approach, and it's that you should always have at least 2 of every role in your application that's dealing with our messaging stuff. You should have 2 senders. You should certainly have 2 receivers, you know, because if one is rebooting or one is having a problem, you're down. You're going to lose stuff. Or it'll just pile up and eventually get stale. The other is to have 3. Like 3 is an important number here. You'll see this in Service Fabric. It'll be odd numbers, usually greater than 3. If you're serious about availability, you need to have 3, whether that's with us or with MQ or with Kafka or anything. And that's because you have 2, and then you have to do a patch, like update something. So you're taking one of them out of the rotation. So now you only have 1. So if something even minor goes wrong during that window, I guess this phrase you could use in the US is you're getting caught with your pants down. So you want to be careful of that. Oh man, I could totally make a Clinton joke here, but I won't. I'm saving those for later. So another thing that I see a lot is that people use more namespaces. They're kind of thinking that this is going to help their availability. And sometimes it does. Using more namespaces in the same region may help you get more availability. It probably won't, especially if you create them at the same time. The way you can see this is you can just ping your namespace, and what you'll get back is the IP and the DNS of our cloud service for our gateway. So you can actually see which cluster you're on of our clusters then. We have like 150 clusters or something, but some regions are only 1 or 2 clusters, and some regions are 10. And what we do is we fill them up to a certain level that we're comfortable with, and then we seal them, and you come back next month and create a namespace, it'll be in a different cluster. So you are getting more availability there, but it's still in the same Azure region, and most likely it's still on the same Service Bus cluster. So you're not really getting much there. Some people are surprised to know that that's not the improvement they hoped it was. About the ping thing, it's interesting. That's actually you'll get a stable IP from that too. So like you do get some cool stuff, and you can see exactly which cluster you're on. But don't get too carried away with this because you can't control it, and we can't do much for you. We can't move your namespace, at least now, from one place to another. So let's talk about common DR models for Azure messaging, and this kind of bleeds into and continues what I talked about last year here. The first is that we have like a dual region active passive. The second is that you would have a dual region alternating active active. And the last would be a dual region duplicating active active. Importantly, all of these say dual region, right? Like, yeah, at least 2. So all of these in common, they have 2 namespaces that exist in 2 different geographies. That's pretty important. And that every sender and receiver knows about both of those. So this is kind of what I talked about last year, is that you can do this today, and if you're serious about what you're doing, you should be doing this today. You know, namespace in region 1, namespace in region 2, you follow one of these patterns, and you'll get better availability. You'll actually get disaster recovery out of this. Key aspects here are that there's only, for the first one, for the active-passive thing, there's only one region that's active at a given time, hence the name active-passive. You are going to do a cutover, and you need to figure out if that's going to be client-initiated or service-initiated, and it won't be from our service. So you need to come up with your own mechanism for that, some sort of control signal. It could be something as simple as a file in Azure Storage or some HTTP service you stand up that's behind Traffic Manager. There are some really good things here. This is relatively easy to implement, and it supports pretty much all of the features that we have. There are some not so good things here. Coordinating failover is still kind of tough because your clients, if your strategy is that every client has 2 connection strings and when it can't get to one, it's going to fail over to the other, they're not going to fail over at the same time. So you might get some funky state. So synchronizing changes that way is tough. The next one is looking at like an active passive with state hydration. This is a variation. I wanted to draw some pictures of this, but I didn't. I'll just talk about it. This works like before, but when you think about something like a telemetry stream, like an event hub, you're probably reading it and doing some sort of data processing there. If you're doing something like moving averages, that means you have state. You need so many points to make the average. If it's like a 5-period moving average, it's like signal processing type stuff. So what you can do is follow a few patterns to get there. When you cut over, your new place isn't going to have any state, so it's empty. So what do you do now, right? You can do things like use topics and have a special subscription that you read from just to replicate the data. With event hubs, you can add another consumer group to do this. And now, actually, something we just released last month was that there's an archive feature for event hubs, and you give it your own storage account anywhere in the world that you want, and we will write your data in time and size window that you specify to that storage account. So it's leaving our system and going into yours. So it's now something you have more control over. You do have to be aware that there's cost for that, and there's actually a cost for crossing zones. So you want to pick your zones carefully there. So far, we've actually found that people like this feature more for DR than we originally planned it for. The alternating active-active, this one's pretty popular with a lot of the teams within Microsoft. The Office Nexus team does this a lot. Key aspects here are the clients are just always alternating between regions. So they're basically just doing round robin on a geographic scale. Failures are retried on another region. That's an important thing to keep in mind. Like you don't want to just keep trying the region that failed all the time. There's a really cool pro to this, and that's that the failover is automatic for you. Like you're just running, and it's 2 a.m. on Sunday, and you're sleeping, and stuff just happens. It's okay. It keeps running. The downside here is that a lot of advanced features won't work anymore. You're not going to have convoys or sessions. Things are geographically distributed, which means that you can't have order anymore, and you'll get some latency. So you're making a choice here. The automatic failover is pretty nice, but if you need those features, then it's not so nice. And then the federal government approach, in the U.S. at least, which would be that duplicating active-active, would be to just send everything everywhere. This is an interesting pattern. I've seen it done successfully, specifically with people who do more time-sensitive type stuff, like broadcasting, where they'll just send to a bunch of places and read from them. The key here is that every message is sent to both regions. I've actually seen it really successfully where they're sent to 4 regions. So dealing with duplicates becomes your responsibility. This is where you need to make your next step idempotent. And you can use some sort of voting scheme to make this a little bit more predictable. So if you had 3 regions, you'd require 2 to be arriving at the destination within a time window. Doing the voting stuff gets complicated. The pros here is this is also pretty easy to implement, especially on the send side. It's just send to everywhere. There are some subtle details here, though. There's more cost. There's more cost in sending. You get into a place where how do you decide what's right if you're only sending all the data to, or 80% of the data to one place and a discrete 20% to another place? Like you get some funny things here, and it can't support strict order because the order will be different depending on the region. Like what if you get a failure sending to one place but not to another? And I will just warn you on voting schemes this time of year that you want to be real careful how you pick these things. You're gonna be living with the results for a while. So we'll see how that goes. So we're pretty much caught up with what I talked about last year here. And all of this is stuff that's probably not made me any more of your friend. I'm just telling you stuff you have to do. Like I'm totally stepping out of any responsibility to do stuff myself to make your life easier. That ends now, though. We are introducing a feature for the messaging services. It's coming up very soon that tentatively we're calling GeoDR. And what this is going to give you, DR is important to say here because it's DR, not HA, is that it's a dual region, active passive, without all the client coordination failover stuff. So what we're going to do is give you a single, stable connection string that's fully qualified domain name. You'll communicate with that. You will have an explicit control of the failover. So it's a separate REST call that's going to be global. It will not be to a single region, to that FQDN, which is floating around globally, and you can control when we redirect the traffic from one region to another. And this is user-controlled RTO. This is what we're giving you now. So we are taking the first of those three models and giving you that. There are some subtle things we'll have to talk about here, but let's talk about how it works real quick. First thing is that you create an alias. The alias is going to look to you just like a namespace. You'll give it a name. You will not pick a region. Then you select regions for your primary and secondary, and you select names for them. So you're going to say, okay, my primary is in Hong Kong, and my secondary is in Singapore. We are not going to, at this time at least, let you put them in the same region because it kind of defeats the purpose of the whole exercise, although that's something we might think about in the future. You select your secondary region and its name, and what we're going to do here, then, is we are going to be copying all the metadata. So this is the queues, the keys, importantly, any things like topics or subscriptions or other lower-level stuff that you're creating in the namespace. And this will be for all three of our services, for Event Hubs, for messaging, and for Relay. And we will copy the metadata between regions. We'll do this in a fairly short window. Right now, we're at about 5 seconds, I think. You will call that REST call yourself explicitly to initiate the failover. And what we're going to do when that happens is we're going to break the pair. So you've established a pair behind an alias. And what we're going to do is eject the primary from the pair at that point and stop the metadata sync. I'll get to why we do this in a second. The alias connection string continues to work for send and receive. So your senders don't even know that failover's happened. Failover is probably going to take a couple minutes. Some DNS work has to happen. But what you're getting, and we will give you a firm number before we release this, is you're getting a time window. You can say, this is the window it will take to cut over, and then you can add what's your window of tolerance for pain to cut over. The previous primary is left untouched. It's no longer part of the pair. And now you need to establish a new pair at some point when you're ready to a different namespace. In pictures, because I like pictures, this is kind of how this looks. Your traffic's coming in, your traffic is coming to the alias. We've got a sync going on. When you trigger the failover, we're kicking out the original namespace, and your traffic is just redirected for you. When you're ready to throw in a new secondary, you configure that, and we put the sync in the opposite direction. So the first question that came up when we started designing this is, well, why not just use Traffic Manager? Well, it's actually a fairly good question. The tough part about something like Traffic Manager is it works great for send, but what do you do about receive? I mean, that's kind of an important question, right? Like, where is the data right now? So what we're doing here is giving you something that will work for send and for receive, that you have full control over, that you'll be able to specify your RTO over. Now, we're not giving you RPO stuff yet. Some of those other tricks, like copying or using archive or something like that, are ways you can get the RPO that you want. So there's still work you have to do. But we are solving the first piece of it. Let's pause for a Zen moment here. Okay. I'm finally doing something for you, see? There are some caveats. Always, right? This is a DR tool. It's not an HA tool. It is DR, and there is no state. So we're not going to copy the messages over. It's just too expensive to do that. Our service is running at about 6 million requests a second, 6.5 million requests a second. So we can't actually, in a reliable way that won't impact latency, move all that data between regions, especially if we're letting you pick the regions. So that's kind of tough. You still need to decide when to fail over. We are not going to set this to automatically fail over. We're thinking about that, but so far our strategy is to provide more and more and see how it works for you until we find the right path forward. you still need to decide how your compute will fail over. So if all your compute is IaaS or PaaS or something in one region, if a whole region that service bus is in is down, there's a fairly good, but not directly related likelihood that other stuff in that region will be down. Usually it's not just like one cluster or something is having a problem. That could happen. So you still have to figure out how to get your other important stuff moved to another place. Other Azure services provide good guidance on how to do that. And you have to decide what to do with the old messages. This was actually a big debate in the team while we were designing this, and why I pushed for it to just eject from the pair, is that we're not going to touch them. So you can still use the connection strings to that exact namespace and get the data, but you now make a choice. Is this data you want to go get and read? Do you want to use your normal read process to do it? Do you want to use some different process, because this data might now be old? So you have to make those decisions. And the last is that there's no fail back. It's a fail forward model only. If you want to go back to the original region and you want to use that same namespace, you need to delete it first, because we don't want to take responsibility for deleting your stuff and your data. We want you to take that responsibility. If that's what you want, that's fine. Just delete it and recreate it, and everything's fine. And then you trigger a failover again to go back. So we're trying our best to give you the tools you need to do this easily. The namespace that we're using for the secondary does need to be empty. The reason for this is so we don't have update conflicts when doing the synchronization. I mean, it's that simple, right? If there's something there already and we're trying to create something with the same name, we're going to have an issue. And we don't know if it looks the same. You might have a topic called Bob, and Bob has 4 subscriptions, but now you're trying to create Bob again with 10 subscriptions. So this is kind of tough. So you need to be aware of what is going to be asked of you for this and what we're going to do for this. We are close on this. I was kind of hoping we could show it off here. We're not quite that close. So we are actually going to start private preview in December for this feature. We're looking for people who use the messaging services heavily to be a part of it. It will be public shortly after that. And so this is a pre-announcement. You can't go home and use it today. But some of you, especially those of you who might be coming to the MVP conference or are critical customers of ours, in which case I hope you have my contact info already. If not, come and get it, please. And you'll be able to use this going forward. So right now, I actually want to take a pause for some Q&A. This is Seamus. So he's made a choice about what's most important to him, which was the choice I'm asking you guys to make about availability and consistency. Is most of what I've said about RTO, RPO, DR, and HA making sense outside of the little ivory tower that is Microsoft? Am I speaking a language that is clear to understand for you, for our customers, which is the bridge I'm trying to make? Yes? Any questions about where we're starting with this and why we chose the one model that we've chosen, or how we're going to do this, or any questions about RTO and RPO at all? No questions? Oh, you're good. Yeah, we could. The question's about stopping at primary and secondary and not doing tertiary. We can actually do that. What's interesting here is what we're really doing behind the scenes is making a global repository that's not region bound. So though your stuff will be in that other region, another feature I wasn't going to mention, but I will, is so this geo thing makes you do some work, right? I have to make a plan. I have to do some work. We're also going to make something for if you didn't do any work and California did fall into the ocean, where you can just say, hey, take all the metadata that was there, all the queues and topics and all their keys, and make them over here. That's not going to have the same 5-minute sort of window to fail over, but the data is actually going into a global metastore now. So that's a great question. And the main reason we didn't make it too many, and we can, is that you're still going to have cost associated with this. So if you're using Event Hubs, for instance, you're paying for a throughput unit in the primary. You're also paying for a throughput unit in the secondary. So if people want to pay more, I'll add the feature. That's great. I'm not sure how effective it really is after that point, though. But this is really exciting for using with things like the GeoDR, or the archive feature of Event Hubs, because now you're getting a choice to make a lot more expressive sort of recovery models. Great question, though. Thank you. Anything else? Yes. I'm sorry? Ah, yes. All right. Okay, so if order is important for you, what are your options? This is good, actually. I'm really glad you brought this up because there's some important stuff you still need to do if order is your number one most important thing. If order is important, you should probably have some sort of durable client-side buffer. In the past, we'd made some guidance about using something like MSMQ for that. We're looking at something that's not MSMQ for that. This is important because if you're saying order is the most important, and you'll wait if our service is down, you need to have that data be somewhere safe for the service to come back up. And your buffer needs to be in order, and it probably needs to be persisted to disk so that it's reliable. If order is most important, that is probably the easiest way to do that. The other way that you can make order still work with really high availability is really if you have one sender, and usually to have order you do have one sender, it would be like one specific server or maybe one specific phone sending data. You can actually have the sender stamp messages in the specific order that you want them. And they might arrive out of order, especially if you're doing something like active-active or some sort of geo stuff. But you can then read the messages and reassemble them. It's like a resequencing aggregator on the receiving side. So yes, that's more work for you. Sorry. We are looking at other cool geo stuff we could do. Order is not one of the things we're looking at providing. So yeah, I would learn the tricks about how to do the sequencing stuff yourself, because next time I'm here and we're talking about something really cool, it will be super cool and super geo, but it will not have order. Any other questions? All right, no questions about Seamus? Okay, cool. This is Seamus. I was actually going to use pictures of my bicycle accident to talk about disaster recovery, but I'm alive and it's okay, so I'm not. The bruising is mostly gone from my head, so that's a relief. But I have an amazing picture of my cracked helmet that I'll show anyone who wants to see. Never broken a helmet in half. Do remember to evaluate the session. I guess you can get some fun stuff for this. I want a new Xbox, actually. I don't think they let me evaluate it, though. And thank you for being here this morning. I'm going to give you back 15 minutes of your life before tea time. And thanks.